Alright, let's go ahead and get started. These notes will cover lesson 4 from chapter 12 over volumes of prisms and cylinders. We're moving on to talking about volume. So let's start by remembering that definition. Volume is the measure of the amount of space that a solid encloses, and it's measured in cubic units, cubic inches, cubic meters, cubic yards. That's kind of measurement we're going to talk about. Now, here's our basic understanding of what volume is. Now, you can easily think about it this way. You can think of a prism as being one square that is repeated over and over and over an infinite number of times to make up this figure, one stacked on top of the other, until you get the height. Now, that means I can take that area and multiply it by however many units that height is, and I get my volume measurement. Okay, we have a measure for our area that is in square units. When you multiply by another unit, you get the third power of that unit, meaning units cubed. And that's the unit analysis of how we get cubic units. So in general, the volume of a solid is the base area times the height, as long as it is a prism. Okay, for prisms, the volume is base area times height, where capital B is what we use to represent area of the base, and h is the height of that prism. Okay, and you guys have done this before with these kind of prisms. You just didn't know you were using that formula. In this formula, we would use just basically length times width times height for rectangular prisms. For rectangular prisms, and this is the only prisms that work out this way, we have the volume formula as length times width times height, because the length times the width gives you the area of the base. So in this case, our volume is 4 times 3 times 7, and it really doesn't matter what order you put those three numbers in. And we get a volume of 84 cubic centimeters. All right. Same thing for a cube. Volume of a cube, though, since all three are the same s side length, volume of a cube is that side length to the third power. So our volume here is 8 to the third power. 8 times 8 times 8 gives us 8 to the third, which is 512 cubic feet. Alright, so it's not too hard to find volume of rectangular prisms or cubes. It's whenever we now have other prisms, like triangular prisms, where it gets a little bit harder, and we're going to want to make sure we use this formula. So for volume of a triangular prism, we go back to using base area times height. So those are the things I need to know. Now the base is a triangle, so I'm going to use the area formula of 1/2 base edge of that triangle times h of the triangle, where this h is the height of the triangle. Okay, this h is the height of the prism. These are going to be different numbers. Okay, this h is 25, this h is 12. So our base area, let me move where you can see the rest of my writing, I'm sorry. The base area is 1/2. I'm going to call the base length of the triangle 10, and I'm going to call the height of my triangle 12. This is the height of the triangle. This is the base edge of your triangle. And so I get a base area of 60 square centimeters. Okay, so whenever I go to plug into my volume formula, I'm going to say capital B is 60. So then I just take this volume formula and plug those two in. 60 times the height of your prism. Remember, the height of the prism is the distance between the bases. I'm going to do 60 times 25 and get a volume of 1,500 cubic centimeters. Okay? And we can do the same kind of thing here with our next. Okay, we're going to use the same formula. Volume equals base area times height of the prism. Okay, so here's what we have to recognize here again. Remember, and I showed you this resource in one of the class periods, it helps to highlight the shape that you know to be the base. So in that case it was a triangle. In this case it's also going to be a triangle. Remember, the distance between the bases is your height of your prism. Okay, so h equals 15. That's the height of the prism. Okay, it's not the height of your triangle, it's height of the prism. So we're going to find our base area using the height of the triangle. Now remember, I've pointed this out before, anytime you have a right triangle you want to use one leg as the base, one leg as the height. So our formula for area of a triangle is 1/2 the base edge, we're going to call that value A, times the height of your triangle, which in this case is 18, but we need to know what that value A is. If you'll look up here on the other base triangle, we do have this hypotenuse of 30. Okay, that could be your hypotenuse, C. So we can use Pythagorean theorem to find the value of A. We're going to call B that height of the triangle 18. We're going to take those values and square them to get 324 and 900 respectively. Then we're going to subtract 324 from both sides and get that A squared is 576, and then take the square root of 576 to get an A value of 24. And it worked out nice this time. No decimals, no rounding. We know this is exactly 24. So I'm going to plug that in for that length to get my area. The base edge I'm going to call 24. The height is 18. And then when I plug those in, I get a base area of 216 square inches. So I'm going to plug that in. Remember, the height of your prism we went back and said was 15, so volume is that base area of 216 times the height, 15. So our volume is 3,240 cubic inches. Alright, and that brings us to our next set of examples, which cover volume of cylinders. But this works out the same way that volume of prisms did. We're still going to take the area of our base and multiply it by the height. But the base area could be further explained as pi r squared, since the base is a circle. Alright. And so for these examples, we're going to use those formulas. And if we understand this, we don't have to do them as separate pieces. We can just plug them directly into that formula. So we're going to use the volume formula here of pi r squared times the height of your cylinder. The radius is given to us as 8 centimeters. The height of your cylinder is 5 centimeters. So we just plug in those values and simplify. They do want this rounded to the nearest tenth, and so we're going to go ahead and multiply it all out and round to the nearest tenth. So when I multiply 8 squared times 5, I end up with 320, and then I multiply by pi, and we get approximately 1005.3 cubic centimeters for the volume of that cylinder. Okay. On part B, we're going to do the same thing, but we need to understand some of the information here. Remember, volume is pi r squared times the height of the cylinder. But look at what you're given. This length of 10 centimeters is the distance from one side of that circle to the other. That would be the diameter. The diameter of your circle is 10, so you need to understand that the radius is half of that, 5. But we also need to know the height. Now look at what they give you. They actually give you the distance from one end of the cylinder diagonally through to the exact opposite end, what they're creating for you is a right triangle. If I draw this diameter of 10 in, it's at a right angle to this edge of your cylinder, and this line connecting those two parts of the right angle forms the hypotenuse of a right triangle. So once again, we'll use Pythagorean theorem. All right, for the legs, I'm going to use this diameter of 10, and what I'm looking for is h, the height of your cylinder, and I'm going to use 13 as the hypotenuse. I want you guys to go ahead and solve that for h. By now we should be pretty good at solving for Pythagorean theorem. Find out what h is, and then we will continue. If you need more time, pause the video. Otherwise, this is what we should get for h. We do get a height of the square root of 69. 13 squared is 169, 10 squared is 100, so when I subtract 100 from both sides, I get 69 for h squared, and when I take the square root of both sides, that's what the height ends up being. And I want to leave it written that way so that I don't have to use a rounded answer to do another calculation. So here's what our volume formula looks like when I plug in the values. Remember, our radius was 5, and our height ended up being the square root of 69. And then it becomes a problem that you just need to plug into the calculator, making sure to do the correct order of operations. So we're going to do 5 squared. You can remember that that is 25 and do that part in your head if you'd like, times the square root of 69 times pi. So I would do this part first, then multiply by these two. And this is what we should get. Rounded to the nearest tenth, it's approximately 652.4 cubic centimeters. All right, now that leads us to our next understanding, and this is called Cavalieri's principle. And it says if two solids have the same height, h, and the same cross-sectional area b at every level, so basically if I take a cross-section at every single level possible of these two or even these three, then they're going to have the same volume. And so what that allows us to do is to work with cylinders that are considered to be oblique cylinders, meaning they do not stand straight up. The best way I've found to understand this is to take a stack of DVDs or CDs and just shift them. You're still going to have the same number of DVDs, you just shifted them off at an angle. So the volume will be the same even though surface area is different. And so we're going to try this example 3 using that principle. This principle allows us to use the same volume area no matter if it's a right cylinder or an oblique cylinder. All right, and so we still have a height measurement that is actually measured outside of that figure this time. We could easily measure it inside, but it just so happens that they've drawn it out here. The height is the perpendicular distance between the bases. All right, so it's not the slant height, it's the actual height here. Now both circles have a radius of 15, so I know they're congruent. So we're still going to deal with the same volume formula, and it's actually a lot easier to understand this time. Pi r squared times h. 25 is h. R is 15. So all we have to do is plug that in. All right, and when we evaluate that in the calculator, rounded to the nearest tenth, we get approximately 17,671.5 cubic feet. All right, this example B works out to be almost the exact same problem with different numbers. I'm going to let you go ahead and do that. You want to know the values of R and H to be able to plug into that formula. Why don't you pause the video, give yourself a little bit of time, and check your answer when you're ready. All right, if you need more time, pause the video. Otherwise, this is what we should get. Using a radius of 11 and a height of 44, this works out to be approximately 16,725.8 cubic centimeters. All right, and that's how we find volume. We just take the base area of our prism or cylinder times the height.